In this slide, we are going to see metrics of major greenhouse gases. Now, as we have seen, human activities are increasing the presence of various greenhouse gases such as nitrous oxide and other greenhouse gases like halocarbons. These gases are found at very low concentration in our atmosphere, generally parts per million or parts per billion, but gases like nitrous oxide or halocarbons have got very large GWPs, that is global warming potential. So even if there is a small increase in these gases, so it may lead to significant increase in the amount of heat which will be trapped by the climate system. Then there is a gas called ozone. Now this you might have already heard about ozone's capability to absorb ultraviolet radiation, and when it reaches surface it can have disastrous impact on the ecosystem. It is also a very powerful greenhouse gas. Now humans do not directly emit ozone into atmosphere, but they emit ozone's precursors, that is hydrocarbons and oxides of nitrogen, and these precursors react in the atmosphere to form ozone. Now over the past few decades, increase in these precursors have led to increase in ozone, which has led to trapping of heat. Now another way the humans are changing the climate is through emissions of aerosols or their precursors. Now aerosols have got very peculiar property. They are very small and buoyant forces, and similar to the force of gravity, and they remain suspended in the atmosphere for many days or sometimes for weeks also. Then aerosols can affect planetary energy balance because they reflect incoming solar radiation back to space. So the aerosols have negative impact. Their net effect is to cool the climate. Then they can also affect cloud formation and make clouds more reflective, which will lead to additional cooling. So as a result of human activities over past 2 centuries, the abundance of these aerosols has increased, which has led to more cooling impact, and this partially offsets the warming effect of the increased greenhouse gases. As an example of how humans generate aerosols, so you might have seen fossil fuels burning, and which has got sulfur as impurities. Now when this sulfur is released into atmosphere as a result of burning, these react with atmospheric constituents to form sulfur liquid droplets, and these are known as sulfate aerosols. Also there are other types of aerosols which are produced by humans, which include carbon aerosols, also known as soot, and which is formed as a result of incomplete combustion. Then mineral dust, agricultural activities, then change in surface water features, and particles produced as a result of industrial practices, for example cement production. So these also lead to increase in aerosols. Now coming to impact of water vapor, so this is very important here. Now water vapor does not particularly appear here in this list because although it is climate system's most important greenhouse gas, the main source of water vapor is atmospheric evaporation, okay, from the oceans, and it is primarily removed from the atmosphere when it falls out as rain or snow. So amount of water vapor in the atmosphere is regulated by evaporation and condensation, and it is fundamentally set by Earth's temperature. So if the Earth warms, then the amount of water vapor in the atmosphere increases. If the Earth cools, the opposite happens, and the amount of water vapor in the atmosphere decreases. So emissions of water vapor directly from human activities contribute essentially nothing to atmospheric abundance. So as a result of human activity, there is less or no evidence that water vapor has increased. The only reason for increase in water vapor can be because of Earth's temperature. So climate water vapor's main role is to in the climate change is to amplify the change caused by things like increasing carbon dioxide through a process referred to as water vapor feedback. So a warmer atmosphere can hold more water vapor. Thus an initial warming leads to increased atmospheric humidity. and water vapor itself is a greenhouse gas, so this leads to additional warming. So that feeds back to the increase in humidity. So this is an important process in our atmosphere, and it has got the capacity to amplify the warming. So it can lead to double or even triple the warming which we get from carbon dioxide. So from this slide, the important point is that you need to understand that which of the greenhouse gases has got uh, the different levels of global warming potential, and also increase in abundance since their pre-industrial level, and the fraction of total greenhouse gas radiative forcing.